Okay, good evening everyone. I hope this actually works. I am not super sure it works because the last live stream was like so long ago, so yeah, I'm not even sure if my setup is still working, and it really wasn't working, by the way. That's why the delay, I had to actually reboot to get my camera working, and when it still didn't work, then I had to do some magic, and then it started working finally, so yeah, I'm glad to be here with you today. Apologies for the lags between live streams. There wasn't one reason I couldn't do the live stream. There was usually each week there was something else. Like this week I have late meetings. The other week I need to be somewhere else. The other week I'm coughing like crazy, and I have not the virus which is currently around, but a common cold actually, and that put me away for 2 weeks because my voice didn't work too well, and so on and so forth. Last week again meetings, but hopefully from now on it should be a little bit better, and I guess it is a good time to do it as we are all, well, most of us I guess in some countries are kind of quarantined at home right now. In Switzerland is not so bad yet, but the situation is going slightly downwards, so interesting times we live in, basically. But this isn't a live stream about the external world, the outside world. This is the live stream about technical stuff. So we are going to focus on technical stuff and forget that everything else exists. So at least that's the idea. If you have any questions, today moderator is Foxtrot Charlie. You can see his nickname right there. And if you have any questions, just write to Foxtrot Charlie, at Foxtrot Charlie, at our YouTube or at our Discord server, if you are at any of them. Or if you are on our IRC, it's enough to just write !Q and then the question, and these will be passed to me and I can see them on a screen next to me. This was the idea, if it actually works. Yes, and the bot is still alive. I see already someone is using that. Cool. So what will we be doing today? Probably picoCTF. Since we didn't do that for a long time. I know I can still log in because I actually checked it a few days ago, so that's a good thing. Apart from that, I don't know. If you have any questions, let me know, and I'll try to answer them from time to time, and then we can get to it. I guess I owe you an update on Tout as well, since the Tout is basically delayed already by... It was supposed to be here 3 days ago, and we didn't even start the review process. This is due to me wanting to make a review center website where we can actually do article reviews instead of doing them over email, and that will allow us to automate basically some checks. Not all of them, but some checks. And we'll have everything in one place. It might be a little easier. There were some minor issues with communication before, so I just prefer to have it in one place. And what this will allow us also to do is to introduce external reviewers to the process, people who, volunteers basically, who messaged us that they would like to help somehow, and the new review center will basically allow them to help as well. That being said, don't worry, Tout 3 will come out. We do have enough articles to publish. We do have over 50 articles right now, I believe, and still a couple of them are being written. Up on top of that, well, you can still submit articles actually if you like. They will still make it into Tout, the 3rd edition, the 3rd issue actually. And the wallpaper is even ready. I can tease it a little bit here since I already have it set up, but it will be available for downloading on the website as soon as the issue is out. And we even have the full art, the cover art for the next Tout ready, including the wallpaper, so Tout 4 will also be there. Not sure when yet, probably midsummer, but yeah. And for Tout 3 we do hope to push it out in April. I think we should be able to do it in April. On the other hand, the print files will probably be late again due to, well, one of the things is that the print house where we wanted to test the print files is in Poland, and Poland basically closed the borders, including shipping outside using post, so I cannot order like printing the test issues there. So yeah, we don't know if the print files even work. So that's going to be delayed a bit as well. Now, one question: why is my camera so? Okay, there's something wrong with my camera setting. I'm sorry, I need to fix it, because I usually have it a little bit more saturated, and I'm not really sure what's going on with that. So let me configure the video and change it. Okay, brightness, contrast, no. Oh, color, perfect. This is what I was looking for. Let's do it like this. Whoa, no, not like that. Okay, yeah, now it's a little bit better. A little bit more the usual way, at least. Perfect. So let's go with questions. If my script is still working, under that assumption, you should see questions there. And it's from Foxbridge. Okay, so I have no idea who actually asked the question. So if it says from Foxbridge, that means the question was from somebody who did the question on... Oh, it's from Zero. Hi, Zero. Is this possible that a zip file has one local file header of one file, but multiple central directory headers, and all the central directory headers point to the same file, same local file header entry? If we have a lot of CDH, then all parsers which depend on central directory headers will... Yeah, okay. So this is an excellent question. Basically, the question is, we can see if my... Oh, and this is probably not going to work. Oh, it works. This is amazing. We are going to use this Stellardrone to draw. Yeah, basically the idea is that in zip file you have... Basically, each file has a header, which is called the local file header. And then there is the file content. This is like the compressed file content. And you can have like several of these in a file. And on top of that, at the end of the file, there is the end of central directory, from which you should begin to parse the zip file. And on top of that, there are the central directory headers, one for each file. They are basically a copy of this header with some minor changes, but they are basically almost identical. If you have one, you can recreate the other without any issues. And the question is, can we make these central directory headers, like a couple of them, and all of them would point to the same file? I believe we could do that. I believe this would work without a problem. Now, the only problem is that this file would, we would see in the archive probably several files under the same name. And then it kind of depends on how the file list is structured in whatever zip viewer we are using. Are we using like InfoZip? Are we using Total Commander, Windows Explorer, or like any other archiver? Is it using a list of files, and does it show the files on a list, or is it using a dictionary of file for, faster indexing? If the latter, then yeah, it would just see one file. If the former, then it would see multiple files of the same name. If you try to extract it, I think it would just like extract one file, or rather extract it once, and then ask you, hey, do you want to replace this file because there's another file in the archive under the same name? So yeah, that would work. I think that this might be a nice zip bomb in case of if the file is actually not extracted into a file system, but is rather extracted in memory. So the file name is actually not treated as some kind of a unique key as it normally is. Instead, it's like in memory, you just extract it and you just ignore the file name and you use indexes or whatnot. So yeah, that's a really good question. I think that's what would happen. What would exactly happen really depends on the archiver. This is a nice question, nice idea. Try it, and if you see any other results, let me know. But yeah, that is absolutely technically possible to do this. What is picoCTF? picoCTF is a CTF, which is a Capture the Flag tournament organized by Plate Parliament of Pwning, which is one of the best teams in the world, from the Carnegie Mellon University, and they organize it for high schoolers, basically. So high schoolers and university students and so on. And I'm not really sure when during the year it takes place. I think that's second half of the year, but I'm not really sure. But then they leave it running, so yeah, so we can take a look and we can solve some tasks. I already did, what, 7 of these live streams where I was like solving quite a lot of challenges they had there, and I think we disposed of every easy challenge. Now we're going through like the harder ones. We still have a couple of left, so it still might take a couple of streams to finish them, but as I mentioned, I would like to just like go through all of them. We'll see how that goes. We might do some other live streams in the middle if I figure out a different topic, but yeah, there we have it. And if you want to actually go there, you can go to 2019game.picoCTF.com. Now, speaking of various stuff which I'm showing in the browser, I should show where is it? I should show Foxtrot Labs, which is the page of today's moderator, that's Foxtrot Charlie. So yeah, foxtrotlabs.cc. Check out Foxtrot's website. Cool. Shimon asks, will there be printed versions of Tout, like these from like the first issue which was printed? So the thing is that first issue wasn't really printed per se, as in we did a test print to basically check if it works, to see if our print files work, and yeah, they kind of didn't, because the actual idea is to have the print files on the website. So if you want to print like, I don't know, 100 copies or 50 copies for your friends, or like 1 copy, then you just get the print file and like print it yourself or take it to a print house, right? Just for free, like it's available for free. That's the idea behind this magazine. Now, from that time, there have been a lot of questions about where can I buy a printed Tout? Can I subscribe to printed Tout? So I would get like each issue when it comes out, and so on. Like so, we might actually start providing them later in the year, near the end of the year. You would still get like for free the magazine. You would still get the print files, which you can download and just take it to a local print house if you prefer. That's like we do not plan to change that. But since there are a lot of questions about like, yeah, like, you know, like I would just want to buy 1 copy from you, then why not? Because when we go to a print house, we can print in better quality than if you would go and print only 1 copy. Because if you print only 1 copy of a magazine, that goes digital print, and digital print isn't the best. It's better than it was a few years ago, but like still offset printing is way better in quality. So if we printed, it would be a little bit better quality than an individual print, and you can still print it yourself if that's what you prefer. And I know some people did it, which is pretty amazing. Actually, we saw some photos on Twitter. So yeah, basically later in the year is pretty possible that we will be printing stuff, but we still, like, first I need to get the review center done. We have to get the print files ready for public consumption, basically, like, you know, be without any issues, which currently they are there. And after we have that done, I can start thinking about setting up some process to, like, for sending them, for like receiving payments, and that requires some thinking. So that's later in the year. Especially that currently trying to do that would be super problematic for obvious reasons. But yeah, there were like so many questions about it that I decided, yeah, let's like do prints as well. Apart from that, I'm pretty sure we will be doing, after each 4 issues, we will be doing a collectioner's edition print, which would be a little bit nicer and a little bit more expensive on the cover, with like, yeah, like large book format, basically, with hardcover and so on. If you want to have one on the shelf, I like books, right? Which is quite obvious. So yeah, I want one on my bookshelf. Yeah. Okay. Cybora asks, I see you use Python a lot in the CTFs. You also use or are interested in Golang? No. So I use Python because Python is super easy to use and super fast to use. Golang isn't bad, but it's more on the low-level side of languages. It's more verbose. You have to write more code to get the same thing done than in Python. In Python, you just write like a couple of lines and everything works because of syntax and because of total disregard to performance, because Python is a super slow language. Golang is pretty fast in comparison to, is really fast in comparison to Python actually. But that's one thing. So that's Python, right? Apart from Python, it's useful on CTFs to also have a language which is fast, because sometimes you need to write a brute force for some weird problem, and Python will just not cut it. Python will be just too slow. So I prefer to use C or C++. If you prefer Rust or Golang, yeah, totally go for it. If you think you can dispose of Python and just use Golang, that's fine as well. The last time I touched Golang in all honesty was 2009-ish, just after it came out. I've written a ray tracer and I like put the language aside, that's it. So I have no idea about the state of the language currently. I know some people are writing some like really cool stuff in it, so it is a decent language. If you like it, just use it. Ropuch writes, hello, could you explain a little what a symbol table is? I'm learning Python and assembly x86, and Python doc is often referring to set table, and object files from NASM also have that. Okay, so a symbol table, there are like, I would say like, let's say 2 definitions for that. But at the end of the day, it's a term from low-level programming, from binary files basically. It's if you have a variable name or a function name, then like there is no reason for the name to be there, right? To be compiled, because like CPU doesn't care about names at all, right? Now, during compilation, when you have multiple binary blobs and you want to merge them together into one executable, like it's called linking, obviously, during that, the linker absolutely needs names to be able to do that. That's one thing. So the linker needs names, right? And the names of the functions, names of the variables, the symbols, as we call them. That's one thing. And the other thing is that when debugging, it's super useful to know that, hey, there's like weird address in memory, what is it, right? And because like normally in machine code, you do not know. A symbol is then a name, a variable name, an object name, which is associated to that variable name. So a symbol table basically at the end of the day, and when we were saying that we are downloading symbols for something, that means we're downloading that metadata, which are the original variable names, original function names, object names, sometimes also structures, like metadata about variable types, not only, you know, names of the variables, but also the types. These are the symbols. And how they are written in a file really depends on the format. Like Windows executables use I think 1 or 2 different formats. On Linux, you can, I think there are like at least 2 or 3 different formats how you can store symbols in an ELF file. So it really depends. But yeah, but there you have it. It's basically like the high-level names which are associated as metadata in a binary file. They usually point to the place in the binary file or in memory where the given symbol is referring to. They are absolutely not needed to run it. You can strip it. There's a strip command which just removes the symbols. You can have them in a separate file as well, by the way, like PDB files, for example, on Windows, which are somewhat popular. On Linux, you can also have an external ELF file which contains the symbol, which is how kernel symbols, for example, are usually, or like packaged symbols are like published, I guess. So that's symbols. First, like if you're interested about the details how they're encoded, just take a look at the COFF or like the ELF specification or like the PE specification is written there. You can also look at the dwarf symbols, like, you know, ELF. So ELF has dwarf symbols because, yeah, naming is fun. And yeah, there you have it. I'm not sure about symbols in Python though. Python doesn't really have symbols per se. Or rather, Python is an interesting language because for some reason Python needs symbols for some function, at least the default implementation of it. The same with Java. Well, that's typical for high-level languages, actually. Okay, hi, can you... let's do last 2 questions. Let's do 2 questions, and then we are going to go to picoCTF. What the web asks or says, "Hi, can you explain how you reason about creating new web challenges for CTFs? I'm creating one on my own and it seems web is the most time-consuming and difficult to think of new ones." I'm not sure it's... I think if you want to make a good challenge, regardless of the category, it's going to be time-consuming. That's how it works. Let me think. I don't think I've made a lot of web challenges. Well, no, but that's not really true. I've done some. Usually in my case, it's like this. I start from the other side. I like figure out what kind of trick I want to show whoever is going to solve it, or I want whoever, like the players, to figure it out during the CTF. And from that, I try to make a story around it and put that into a task. And it really depends what is it, right? Like, it might be, I don't know, like hash extension or whatever, which kind of is crypto, but you can put it in a nice web scenario, or it might be like HTTP pollution or some other stuff. And then I have this trick and I try to make a story around it, make a website around it, and then write it. It does take a lot of time, but if you want to, have good challenges, then they require some time to think about them. That's normal. They still do not take as much time as, for example, hardware challenges, which you actually need to design, have PCBs made, and actually make, solder them. That takes a lot of time, and test them. Yeah, so that's my approach. I'm not sure if you have any other questions, follow-up questions, just let me know. Where is abstract zip? Abstract zip is in random places, but I think if you look actually for abstract zip, you should find it, or like ginveil abstract.zip. Yeah, here on my blog, it seems 523 is the ID of a post, and the weird zips, this will contain the abstract zip. If you're wondering what's abstract zip, it's a zip which is basically made as a multiple personality file, as in it actually can be seen as containing 4 different files depending on which type of extractor you're using. If you're interested, look at my videos and slides about zips, since I talked about it, I think, on most of my zip presentations. It's a cool party trick, basically. It's useful for testing. We have some infrastructure processing zips as well. What do you think about the new bug in SMB is WannaCry coming back? I didn't analyze it, but it did sound kind of scary. I was thinking like if I actually have to do some patching or hardening in my local network, but I think I'm fine. Yeah, but like I always it's always worrisome and bug in SMB, which is the file sharing protocol for Windows, or Samba as Linux folks like to call it. Then we have remote desktop protocol, RDP, and then there are the RPC protocols as well, and the NetBIOS protocol. Like, if there is a bug found there, especially like a pre-authentication bug, then yeah, it's usually bad, as in a lot of people can get infected due to that. So it's quite amazing that someone found it, but let's hope. I mean, we know that malware is going to be using it. Let's look at the challenge, and after we look at the challenge, we can go back to questions. So yeah. Okay, we have solved 72 challenges, we have 26 unsolved. This is absolutely a lie. We already know that there will be more challenges than 26. And I still do not have a setup for you folks to hear voice from the steganography challenges which require voice, but so that means we'll be skipping that today. Okay, I do need to open my folder with my solutions to... where is it? Okay, here we go. Now I have my folder with... Oh, we made quite a lot of streams about this already. Okay, so what this is, these are solved, so we do not want solved, we want unsolved. And yeah. Okay, so this is interesting. Foxtrot says that I'm losing some frames on video, and which is quite interesting. I do not see it in the playback. I will take a look later when the video is archived, because I did have some issues with the camera, so that might be the reason. I will try to look into it later. Okay, forensics, this is the one requiring sounds, I'm going to skip it. Rockstar was a weird one. It was like general... Basically, the last Rockstar was we had to find some weird language. We can take a look. Okay. If it's, again, a weird esoteric programming language, which we have to find. Okay, one thing which I like to do is I like to... Let me maybe make it a bit bigger. I like to select everything so we can see if there is any funny space stuff going on after each word. And there is some funny space stuff going on here. Why are most but not all of the lines, why do they have so many spaces? And are these only spaces? Maybe it's a tab. And so it's like this. If you're looking at white characters, which means characters which do not actually display anything, there are multiple types of white characters. Like previously in when ASCII was dominant, right? There was a tab, then there was a space, then there was something called a vertical tab, and then there were like two end of lines, right? That's about it. Now, in the era of Unicode, we have also non-breaking spaces, we have breaking spaces, we have half-width spaces, we have full-width spaces, and we have zero-width spaces, which might be breaking or not breaking. So there are different kinds of spaces, like characters which do not actually show anything. Here, this character is represented as a dot because that's what Sublime does, but let's look at it in a hex editor, and see what do we have there. So yeah, these are basically spaces. What I'm looking at now is, are there any tabs there? Or is it only spaces? It's only spaces, so that's fine. It might be a red herring, meaning it might be like totally... The task might not be about it, but since this is the first thing I've noticed when looking at it, I decided, hey, maybe it's actually it. So yeah, what I'm going to do is I'm going to launch a console, and I'm going to... Hey, one thing which changed in my life is now I'm remembering to do IPython instead of Python, because I'm writing some Python recently, so yeah. Cool. Okay, so let's open the lyrics. Does it have tab completion here? Oh, it does. That's amazing. I should have really used this in the past as well. Let's read it, and let's put it in K. So K we can do K split lines on it. So now we have the lines here, and what I'm interested in is I'm interested in the count of spaces. How many spaces are these? Maybe these are like the letters in an alphabet or something. We can figure it out because like I don't know what's the longest, but this kind of looks like, is it 26? Maybe a little more. We figure it out. First, I need to actually get the number of spaces after each line. I'm not sure if the number of these characters actually has anything to do with it. Maybe like, for all I know, the flag could be like this, RSATMV. I don't know, but currently I'm focusing on the hypothesis that the spaces have actually something to do with it. So what I'm going to do is, I guess for each line, I'm going to look for how to split it. Is there a nice way to split it? Because what I need is like the number of spaces at the end. I'm thinking there's like a fast Python way to split it. I don't know. Okay, and since I don't know, I'm going to just write a function like how many space, like space counter sc. And it's going to get a string, and then it's going to, this is like ugly code, but that doesn't matter, we're going to run it only once. So let's do it like this. This is C is the counter, then for character like ch in the string, but I want to reverse it, so I want to go from the back. If the ch is a space, then I want c to add 1 to it, otherwise I want to break. I actually don't want to break, I want to return c, but okay, whatever. Okay, so now let's see sc of k of 0. Yeah, 14, perfect. So now for each k, so for each, well, entry in the k, let's call it x, I want to count it. So sc of x for x in k. And we have now this. Let's see what's the maximal number here. It's 37, which is absolutely weird, but okay, I don't know. So I'm going to assume these are actually indexed in the alphabet, but starting from 0. Or maybe 0 is a special character for all I know, I don't know. And to make some heads or tails from that, I'm going to do chr of ox41, which is a capital A. And then I'm going to do quote quote join, and yeah. Does this look like a flag? No. Okay, so let's work from the backward. We know the flags usually begin with picoCTF, right? But like all the flags we found before began with picoCTF, I believe. I'm pretty sure we can, yeah, picoCTF flag. Does it say something else? No, put the flag. So okay, it might not actually be it. So that, for all I know, that might be the flag. Okay, I'm going just to test it, because why not? And it's not the flag, it says incorrect, which is fine. Now I'm going to add 1 to it, because I said that is actually from 0, maybe it's actually from 1. So in that case, I'm going to subtract 1 from it. Does this look more like a flag? No, it doesn't at all. Okay, then let's work the other way from it. So we know the flag, oh no, I wanted to say we want to work from the fact that it begins with picoCTF, but it doesn't, because we have to add the picoCTF. So what do we do about it? We can actually do this, but let's do it like this. For k in range, I don't know, 20 to 7e minus 37. I want to do a print of this. And here, this is the 41. I'm actually going to, no, I'm making a mistake. I don't want it to be named K. I want it to be named A. Okay, now. And now it gave us some more strings to work with. Is this anything here? Does anything here look like a flag? I do not think so. So given this, I am pretty sure now that this is actually a red herring. And if this is a red herring, then I might want to try different things. I'm going to take a look at it for a couple of more seconds though. No, nothing looks like a flag here. Because the flags are usually, they're not random, they're like some sentence or something. It doesn't look like that here. So back to the drawing board, basically. Why 37? 37 because this is the maximum number which I found of spaces. That's why I said like 37. It's just an arbitrary number. I can change that to anything else. Like I can just make the full range, which is going to be a kind of weird, but I don't mind. Yeah, not that it helped a lot. So that might be a red herring after all. What about, so spaces is one thing, but what about if we take like the whole line instead of just spaces, then the whole line length? So how do we do that? We basically do, let's start from 0, which is going to be kind of hilarious. And then instead of counting the number of spaces, I'm going to take the length of a full line. And again, there's a lot of garbage here, but I don't mind. Did anything change here? Does anything look like a sentence? No, I don't believe anything looks like a sentence. There might be another idea, but it might be that we have to take like the length of the characters, like 18 and then 14, then 16 and then 16 again, then 24, and after 24 we want to take 8, which is kind of weird than 40. But I'm willing to give it a try, but before I go there, because this is going kind of to a rabbit hole of weird ideas, so before I go to weird ideas, how about we do some, we check some other idea. Okay, now I'm looking if I missed anything obvious, but it doesn't seem so. So, what does the text actually say? Rock and roll is right, silence is wrong. Okay, this is already interesting. Rock and roll is right, silence is wrong. Does that, like, these are the spaces, right? So are the spaces... Okay, let's just keep reading because it gets better. A guitar is a 6th string. That probably means 6 bits. Tommy's been down. Music is a billboard burning. Razzmatazz. I have no idea what's a razzmatazz. I'm sorry. What's a razzmatazz? Okay. It seems it's a dance hall in Barcelona. Okay, fine. Listen to the music. If the music is a guitar, say keep on rocking, listen to rhythm. Okay, so actually it might be that this is again some esoteric language. And the esoteric language is actually going to be using the white spaces for something. Yeah, what was the esoteric language we used last time? Anyone remembers? I absolutely don't remember. I'm going to take a quick look if I made any notes. Okay, then we have a transpiler. Okay, is there something I can in Rust online version? I think we tried this and it didn't work too well, but we can try again because why not? Yeah, it looks the same, right? So it's again probably the same as the third language. But it doesn't like it, so let's see if there's any other language. Okay, this says it's an online compiler. Does this work? No. Okay, what do I have to do to compile this? Yarn. Yarn, is this in JavaScript? It is in JavaScript. Thankfully, I did install Node.js recently, so but actually, I am going to, I guess, download it. So like this. Okay, now let's go to Rockstar and I don't know, what is there, like a yarn build command or yarn run? Oh, there is no. Okay, that's fine. Oh, it's in Python. What? I'm getting confused. Okay, what does it do? That's a weird thing. Why does it even do it? Is this the interpreter I'm looking for? Yeah, probably. Okay. Deploy picoJS serve. Let's just do serve. Okay. Is this what it's doing? Yeah. Okay. So now it's supposed to. Let's copy the. Or let's actually make a file which is called like asdf dot. What was the file name? I'm going to. No, I'm probably just going to copy the lyrics here. So let me copy the lyrics here. This is called. Okay. And let's call lyrics. Okay, and I just downloaded it. It's probably serve is not what I want. Let's do it like this. I have little idea actually how to use Node.js. Oh, the online one is working, you're saying, the official one. Do you have the address of the... Oh, okay, there is one. Thank you for the blame drop, thank you for the address. Code with Rockstar.com. Okay. Try it. Oh, it is working, thank you. I'm going to copy paste it here then. Input, I don't know. Program completed. Is this the input? Let's put the input here. Program completed, input, output. Where's my output? Rock and roll is right, silence is wrong. I don't know, this is like a guessing challenge again. It's like do something with I'm not sure about this. Let's see at the docs if there's actually a hint here somewhere. So okay, the comments are strongly okay. Comments are in parentheses. 3 kind of variable names. Simple variable. Okay, is a variable. So okay, rock and roll is right. So this is like an assignment to a variable. Okay, so my variable is cool. Last variable, okay. Tommy's, is this like also a short way to assign the variable? Probably is. Okay, listen. What is listen to music? This is the first thing which is probably not a shout. I'm trying to analyze this, like reverse engineer what this program does, but this isn't. This is like a weird syntax. You can convert it to Python. That would be awesome. How can I convert it to Python? Is there a transpiler somewhere? Or like compiler, however you want to. Oh, there's actually like a, how do I use it? Okay, hey, if we can do this, but someone mentioned on chat how to install a package. Okay, npm install. Npm install readline sync. Yeah, it's actually working. Honestly, like the only time I'm using Node.js is on some CTFs. I started playing with some React.js recently, and it also uses Node.js and like Yarn for some reason. I have no idea why, but okay. Seems to be a popular thing nowadays. What? Oh, it doesn't like, yeah. Oh my. Okay, let's just ignore it. Like, why does it need links to work? I have no idea. But why does it? Oh, we can do another thing. We can actually move it to a different place. Okay, let's go here. Let's do here. Let's try it again. So what we are trying is doing, but the reason I want to actually get the interpreter running because then I can play with a little bit with it and do. Okay, wait. Get from Foxtrot something. Oh, thank you. Okay, that's cool, but I would like still to reach this point without, like, with actually running the tools myself. So before we get there, okay, but I'm going to use the tool, which you did suggest, Rockstar UI. Where did you find that? Python transpiler. Okay. Okay. Oh wow. Seriously, you can just do this. It's cool. Let's do it. Let's do it from a different directory. Okay. So did it install it, but it doesn't. And it didn't even add it to my path, like what the hell. Okay. Oh. Now it's a little bit better. Now I can take a look at it. Okay. Okay, something works. Perfect. Let's get my lyrics copied here. So that's lyrics. And what did happen? It created output.py. Okay, so we are now at the place which Foxtrot suggested. Cool. Wow. Okay, let's compare this side by side to the annoying esoteric language. Actually, there's a better feature for that. Okay. So right is true, silence is wrong. Okay. Well, a guitar is, how did it get like 19? Why 19? This is 19 characters, you probably don't see it, but yeah, if you look here, it says 20, but I'm guessing it's counting a little different than I am. How did it arrive at 19? How does this arrive at 40? That's 25, 44. This language is magic. Then we have music is 160, okay. Then listen to music and it gets the input and it checks if input is 19. If the input is 19, it says keep on rocking. Then it gets another input and it decreases. I guess the input actually is an integer. And it decreases it by music, which is 160. And it checks if it's false. I'm guessing that's 0. So 160 is the music, okay, and then it prints stuff out. So let's take a look at the online interpreter if we can actually make that, if that actually makes sense. So try it, and we copy paste this. Then input, we said that input needs to be a guitar, which is 19, and then the other input, it needs to be 160, right? Okay, and it still doesn't really, unless the input works in a different way, it doesn't like it, whatever. So Tommy is 66 and it prints Tommy, then this, okay, and it just prints, let's just print this ourselves. Therefore that's 66, that's a B, 79, that's an O, 78, Bon, 74. I have no idea what this is. Then 86. And yeah, we know what it is. It's Bon Jovi. So let's try that. Yeah, that's it. Okay, it's an okay task. I shouldn't complain about it because it's like, the reason it took so long is because I don't really know this esoteric language, so it's pretty okay to have this task on a CTF. I think the biggest help here was translating the esoteric language to Python. Yeah, it's only like a 50-point task on a CTF, I would say. It's more troublesome, or like it's a burdensome task than difficult task. So yeah, well, we got one out of the way. That's great. Thank you for the help on the chat. And yeah, you know, if you learn this language, you can write on your CV that you're a Rockstar developer, Pavel. I think you're absolutely right. A Rockstar developer, perfect. Okay. Forensics. We have recovered a binary and an image. See what you can do with it. Let's do this. This sounds fun. More fun than doing Rockstar analysis. And download, okay, download. So we have two files here. And do I have any? Wait, what's going on? Okay, we can shut this down. We can shut this down. And we have two files now, which is an encoded BMP, which looks like this. Absolutely amazing. This is like modern art. And then we have a mystery file, which is an ELF and a 64-bit ELF executable at that. So a Linux 64 bits. It uses some open puts, and as in previous tasks of this from this category, this is probably what took the flag and it generated the image based on that. And we have to analyze it. And after analyzing it and getting the output image which we have, this is the output image which we have, right? We can reverse the process, basically. This is what the task is about. And I kind of hope that the task isn't about like measuring the sizes of these structures, because that's kind of what it might be all about. Oh well, let's put this into IDA. Why did I skip GOT? Because I don't feel like binary exploitation right now. We can do it another time. I mean, there are so many tasks to solve. Okay, so this is IDA, then it opens the flag, it opens the original, and it opens this encoded for append. Why does it open it for append and not for writing? Is there anything at the end of a file? So something we have not checked, and I'm always repeating that we should check it. But there does not seem to be anything at the end of a file, just like this weird color. Yeah. Okay, that's fine. What kind of a BMP is it anyway? Is it a 40? Where is this info button? This is an 8 bits per pixel, 256 pixel bitmap. Okay. Now, what's weird here is the size of it, actually. Because this size is not divisible by 4, it's not a standard size, it's a pretty weird size. Now, BMP is a really fun format. There's one steganography trick, which actually there are a lot of steganography tricks in BMPs. I guess if you played my tasks from like Confidence, there was a, I think, 7 or 8 level challenge with like a different BMP steganography trick in each of them. Anyway, so one of the tasks, one of the tricks is actually like this. But in BMP, let's go maybe here so I can explain it. All right. Oh, come on. Yeah, so in BMP, if you have an image, first of all, the image is encoded like upside down for some reason. So the first line encoded is this, but that doesn't matter here at all. Now, what matters here is that the size of the line of pixels is in bytes is actually, well, you know, the color depth in bytes multiplied by the width of how many pixels there are in the line, right? That's easy. So that's that's a pretty standard formula. So that's like, if it's bits per pixel, then you just divide it by 8, right? Now, this is the size of a line. However, there's also a term which depends on which library you're using. It's got like a pitch, a full size, or whatever, scanline size, whatever you want to call it. It's basically that, but it's rounded up to, for example, the nearest how do you say it? As nearest value, which is dividable by 4, for example. It's aligned to 4 bytes. So in case of BMP, this alignment is always to 4 bytes. So even if like this is the image itself, like yeah, it's cut here, then you still might have some bytes encoded which just align it so that one scan line, one full line, is like the size of it can be divided by 4 without any problems. This was used to, I think, like kind of make it a little bit hardware friendly back in the days when alignment played more crucial. Well, currently it's also alignment is pretty important also, but yeah, whatever. Like, I think it was an optimization in the format. That being said, That means that if you have like a weird value of the width is a weird value which is not divisible by 4, then the alignment will be there, which there will be some bytes which align it to 4, right, to the width of 4. For example, if you have 1 and you multiply it by like 8 bits, so this is like 8, which means this is 1, so you multiply it by 1, which means you have the line size of 1 byte, and then you have 3 bytes following that of the alignment. And given this, you can encode any data here. Like you can just put data there into this row here, because it's never displayed, but the data will be there, it will be preserved. The specification says that the data should actually be zeros. It should be zeros, but nobody checks it, because why would you check alignment, right? So that would just be a waste of cycles. It's just like you do not do anything with it anyway. Given this, you can just put some hidden data here, and this is a trick which you can find on CTFs. So what we can do, even without analyzing that application, we can take a look at the BMP and we can see if there are any. First of all, we can see what is the alignment, and to do that, I'm going to launch again Python. Let's actually do it in, oh wait, that's IPython 3 anyway, that's perfect. So what's the size? The size of it is, 1765, and like we know there's 1 byte per pixel, right? So is this divisible by 4? No, it's not. 1 is the rest, which means we have to add 3 bytes of alignment to actually make it divisible by 4. So yeah, we know there are 3 bytes of alignment after each line, after each scan line. So yeah, we should actually look for these bytes there. Like, an easy way to do it is like just look around, but we probably don't want to do it. This is, by the way, the color palette, because we know there is a color palette. So the image itself actually should begin somewhere here. This is where the image starts, at this point. So what we can do is we can actually load it in Python, because why not? So open the encoded BMP, read binary, and we put it in here as a, I don't know, byte array or whatever. Okay. So now we basically just get rid of everything in the header and in the palette. And to do that, we do OX43. The other way. 43 what? 1, 2, 3, 4, 5, 6, 6. Yeah. So this is the data. Okay, I shouldn't have clicked that, but that's fine. And now, so this is the data. Let's call it K. And now we know that the size of this image is 852. So for I in range 852, what we want to do is we want to grab that alignment at the end of each scan line. So that alignment, we can just print it. It will be K, then I multiplied by the whatever is the width of that. That's 1765 plus 3, because including alignment. So we grab it from there, no, from here to I times 1765 plus the alignment. Okay, so we grab just the 3 bytes which are at the end of each line. And yeah, that's it. This is absolutely not what I wanted to happen. What did I do wrong? No, yeah, I need to do something like this. 6, 5, and here plus 1. Yeah, this is now grabbing the end. Okay, perfect. So this is like 800 something, right, of these. But no, it's just like the alignment is just zeros. So this was not a way to actually solve this task. It seems the alignment is clear. There is now no information, there are just zeros. which is disappointing, but is worth trying. So let's go back to actually reading the code in IDA, as we should have done. We know that what we should have done, but at the beginning. Cool. Okay, so we know it's nothing. There's nothing at the end. We know this is not it. So what's going on here? We are. What is this? 2000. Okay, so from 0 to 2000, we add a character to pointer. What's pointer? This is where the original BMP is actually read. And this is the encoded BMP. So we grab what? First 2000 bytes of this. I do not fully understand, but does it just... What is it doing? Oh, okay, now I get it. Yeah, it's copying the first 2000 bytes. That's what's going on here. So it copies the first 2000 bytes, and after that, it reads from the flag. This is the flag. Let's just call it flag file. So from the flag, it reads 48. Is this 48? No, it's like 50, right? Yeah, it's 50. 50 characters. And then it somehow encodes them. We will check it in a second. Where does it put them? And that's the interesting thing. And does it just put them at the offset 2000? So we still have D, right? 2000 to 2050. Is there anything fun there? Doesn't look fun. Okay, but it just puts one character, right? It encodes the K. K is left of 7. No, the value of 8 here might hint us that it's actually doing bit by bit output. And what we give it is we give it the flag. J is from, okay, the flag, which is, we know is 50 characters. -5, why do I put -5? I don't know, that doesn't matter. And then the pointer, we also give it a pointer. And at the end of the day, it puts whatever this encoded character into the output encoded flag, and then it reads. What's this pointer? Oh, so it kind of combines. It seems it kind of combines the character of a flag with whatever is there. Given on this, what I see here, even without looking at the coded character, I'm kind of leaning into thinking this is a least significant bit encoding, which might actually be true. If it is least significant bit, we are actually like a little bit too low on the count. We should do it like this. Okay. And yeah, we can see that there's this change between 8, 9, 8, 9, 9, 8, 8, 8, 8, 9. Like the least significant bit is changing in these, which means I'm going to take a look, but this is just probably least significant bit. Yeah, totally. It's grabbing the bit from the number, like this first argument. This is the number of a bit, which is grabbing from 0 to 7. A2 is our character, which is encoding, and then it grabs it like that one bit. It grabs that one bit from the character, and then it masks out the pixel. So basically, if the pixel which is there is like 1 0 1 1 0 1 1 1 1, for some reason this is the pixel which is there, right? And then on this side it got like a 0, for example, right? So on that side we have 0. What it does, it applies this mask. This mask is 1 1 1 1 1 1 1. Can we do a little space here? It actually aligns 1 1 1 1 1 with a 0 at the end, which means that the result of this mask is actually going to be 1 0 1 1 0 1 1 1 and 0, meaning, well, we just copied this part was copied, and this here was not copied because there's a 0, which means we mask it out. That's why it's called a mask. We mask it out, so we just put 0 here. We masked out whatever was here. And the rest we just copied. That's how masks work. And then we grab whatever value was here, we got from here, right? This is the 0, and we put it using this OR operation here on the last position. So this is called the least significant bit steganography. It's like super standard. And yeah, you can like figure it out even without knowing about it, without reading ever about it. Cool, so what we need to do here is we need to grab these bits, and after we grab them, so how do we grab them? We do X, we just grab a bit for like X in this. So these are our bits. Now what we need to do then, we need to merge them. I'm actually going to do it in a nasty way. Please do not look. I'm going to do it like this. I hope you are not looking. Okay, and now I'm going to do bin on it. Not bin. I'm going to do int on it. Int, and I'm going to do 2 to decode it. And so yeah, and now I'm going to do hex on this. So yeah, I decoded this as a binary number. Now I'm going to do, what's going on here? I don't even know. Okay. Alright, I'm just going to do, like on out 15, I'm going to do hex to encode it as hexadecimal, which is fine, but I think it's actually in reverse, which isn't great, because it's going to be 6D and 6.2 and not the other way around. So what I'm going to do here, I'm actually going to turn it the other way around, like this. Okay, now we got a different number, so I'm going to do the hex again on it. Yeah, this is starting to look better. And now we did see that here we have this -5, so we have to add 5 on each byte actually. How do we do it in a nice way? Byte array, or we can do b from hex, and we can just put this. Okay, this is nice. So now for, or rather, for each character, I want to grab that character. Oh, actually, for bytes, I don't have to do it. I want to grab that character and I want to add 5 to it, and I want to convert it to a character again. So for X and this, yeah. Okay, and now this is by the other way around, which is fine. Now I just do the join again, which is, yeah, it's fine. It's just backwards, like picoCTF, but it's backwards. So let me change it again, like reverse it, and here we go. So that wasn't so hard, but also a little more enjoyable. Yeah, cool, and that's correct. If you have any questions to this, let me know. Like the most magic here is, I guess, my Python code, because everything else should be pretty clear. Let's go again through the steps which I did. The first step was to, so if we look here, right? The first step was to get the data on the given range. We know that there were 50 characters. That was the flag size. It was in, if we look in IDA, we could read it here from 0 to 2 less than or equal 49, which means this is a loop of 50 characters. Then we know there's another loop for 8 bits for each character, so that's why I'm doing this 50 times 8 here. So we grab the data. This 2000, by the way, is, again, we found it in IDA, which is here. And then, yeah, for X in this data, for X, which X being 1 byte, because this is a byte array, right? So for X being a given byte in that data, we grab the least significant bit of that byte. So we just grab this data. Now, OX30 is an ASCII code of 0. So OX30 is 0. If we add to that 0, it's still 0. If we add to that 1, we get OX 31, which happens to be the code of 1. So that's how we convert it into a stream of zeros and 1, but like in an array like this. When we do a join on it, and this join basically like converts it from an array of characters into one string. This is what the join does, like asterisk, asterisk join, and that's it. Then I told you that, hey, this doesn't look good. Well, we did hex on it first, right? We did int on it because it's a string of something, and we converted it into an integer in the binary system. This 2 here is the parameter of an int function, of an int constructor actually, and we tell it, hey, this string is encoded in binary system, so decode it as a binary string. And then I told you here, like, something is wrong because D6 is not a proper ASCII value. It's in the, because ASCII values, like printable ASCII values, are from 0x20 up to 7e. So again, to write it down, 0x20, which is a space, up to 0x, which you cannot see, 0x7e. Let's just do 20 to 7e. 7e being a tilde, like this thing, this sign on the ASCII table. So D6 is actually larger than 7D, so I said, yeah, something is wrong here. And the typical thing to be here is like the order of bits. Was the least significant bit encoded first, or was it encoded last? And maybe the most significant bit was encoded first. So without thinking too much about it, what I did is I changed the order of it. I reversed the string. So like, you know, just reverse the string. Like, don't care about anything else, because that changes also the order of bits magically. I did the same steps and I got this. 7, 8, 31, 2D, this looks much more sane, this looks in the ASCII printable range, so I was quite happy with this. So I took the string, I converted it from hex to a string, like I decoded it. In Python 2, you would just write like this 78 thing here, dot decode hex, right? This is what you would do in Python 2. In Python 3, we do this, and it's the same thing, basically. And we got this, but this is garbage. But again, we remembered in IDA that there is this like -5 here. And given this, we had to add 5 to each character. So I've used another loop like for x in. So this basically took each byte being again 2 hexadecimal numbers, or digits actually. So for x, I added 5 to x, and then I created a character from it. And then I got again an array, and I said that, yeah, I need to do another join to create a string. And then because we reversed not only the bits before, but we reversed all the bits in the array, and not just in a byte, but in the whole array, the string we got was also backwards, which is quite obvious. So what I did at the end is like, again, reverse it, which in Python, you know, but you reverse a string like this. So I get picoCTF, next, blah, 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 and this is the flag. And I believe we put the flag already in the system. Did we? We did. Perfect. So there you have it. Okay, let's do some questions now. So we can close it. Any idea how to get real-world malware samples to start malware analysis? Excellent question. There are a lot of websites which have some samples, and okay. A long time ago, there was something called offensive computing, and they actually had malware samples. But I guess if you just look if you look for malware samples online, you will find some. Yeah, free malware sample sources. Okay, that's fine. There are some malware samples here. Just look for it. I mean, there should be quite a lot of sites which have malware samples. So that's one thing. Another thing is just look in your spam folder. At least in my spam folder, I have a lot of samples. Not sure if offensive computing is still offering the samples. It's a good question. But yeah, like, just look on the internet. People do publish malware samples. No one writes, how to start with IDA and reverse engineering? Which platform is the best for that? my personal take, and again, it's my personal take, is that Windows is the best platform for that, because on Windows, reverse engineering tools are way in front of what is on Linux, what's available on Linux. Though the gap isn't as large as it was a few years ago, in all honesty. Kinda, yeah, degrees. So, and like this has historical origin, since on Windows, like everything was closed source, so people had to learn reverse engineering, and once they learned reverse engineering, then, well, the creators of software didn't really want folks to poke into the code and bypass, piracy protections and so on. So what they did, they applied anti-reverse engineering tricks and so on, and this was like a constant step-by-step battle between the creators of the programs and software crackers, right? Now, on Linux, everything was open source, so why would you develop reverse engineering tools? Why would you develop reverse engineering methodologies? This kinda slightly changed, but still on Windows, the state of art is much higher than on Linux. So I would say learn on Windows, because then you can get your level much higher, and on Linux you will not have to deal with the problems which you will find on Windows, meaning you will not have an opportunity to learn that. On the other hand, learning reverse engineering on Linux is also a little bit easier, I would say, but there are better tools on Windows. Definitely there are better tools on Windows. And how to start with IDA? It doesn't have to be IDA nowadays, right? You can use Ghidra, Ghidra, whatever you want to call it. I don't know what's the official way you pronounce that. You can use Radari too, you can use Binary Ninja. So yeah, any of these tools is fine. There are a lot of tutorials online. There are a couple of books about some of them. So yeah, and there are a lot of tutorials. But and for reverse engineering, I'm going to repeat myself, but this is exactly the reason why I created a certain blog post on my blog. If you go to my blog, just look for FAQ. So this is my blog, FAQ, and how to learn, FAQ with a semicolon, how to learn reverse engineering. Take a look at this post. I try to write everything I know, every advice I ever given there. I might have to update it because that was already 3 years ago. Look there, look in the comments. There are some smart people who commented it. So yeah. Okay, people in the chat say it's Ghidra. Okay, then make it Ghidra. Okay, I gave you links to this post. And I think that's about it for this question. Do you drop frames? I'm not sure. I mean, I see the preview from YouTube, and it looks fine. I don't know, it actually looks super smooth to me. Yeah, I don't know. I'm going to take a look. Do you know any good book about Linux internals, especially covering Linux operating memory structures and process internals? No. There was a book like that, but it was about kernel 2.4 or 2.6, and that was ages ago. I'm not sure if there's anything new. Now, there are multiple articles about that on the internet, basically, which you can find. And, well, it is open source, so you can just read it. That's all I can say. It's a little bit easier to get into that than getting into Windows kernel internals, I would say. But yeah, I do not have any good recommendations. If anyone has any good recommendations, let me know. Oh, actually, they say it's not Ghidra. It's in the FAQ. BlameDrop says it's Ghidra, but the G sounds like G in Go to great, good. So it's Ghidra. Yeah, it's Ghidra. Okay, it's Ghidra in that case. Ghidra, perfect. I will forget that in 10 minutes. Yeah, so I do not have any good book recommendations for Linux, I'm sorry. The Shin on chat writes that there is a free book called Linux Device Driver, which might be a good introduction. Thank you for recommending it. We can actually look it up. Why not? We can look it up if I find my browser. Where did my browser go? I closed my browser. No, I didn't. Here we go. Linux device drivers book. Okay, fair enough. There, like on lwn.net, there are a lot of good articles about Linux internals as well. So yeah, I'm going to give you a link for that. But yeah, it's like it's a little bit old, but it still might be fun. Okay. Hey, I recently obtained a stripped Rust binary I want to reverse, but I haven't really found much useful info online. Do you have any advice to offer? No, I don't. Rust reverse engineering is painful. I feel your pain. There is no way around it. There are some tutorials how to approach Rust reverse engineering, but it is painful. I do not know any good way around it. I'm sorry. Okay, do you have any resources for someone who is transitioning from Linux binary exploitation to Windows binary exploitation? CTFs don't provide much about Windows spawnables. Yeah, that's true. There are some CTFs, but not a lot. So that's a good point. Let me think. Yeah, I think like the most important thing is to read all the available papers about the mitigations which are on Windows, because they're kinda different than what you see on Linux. I mean, like there is the GS cookie, which is like similar to stack canaries or whatever, like stack cookies. On the other hand, there are like encrypted pointers in some APIs. There are some weird protections in the kernel. There are some like control flow integrity checks in some binaries. There are a lot of heap exploitation mitigation. So what you have to do first, I think, is like get on, like read what are the current mitigations on Windows. And from that, I guess like the easiest way is just to make example programs for yourself, compile them with like the mitigation you want to test and exploit it, trying to bypass that mitigation using known techniques or like figuring out new techniques. So that's one thing. On the other hand, there are also so also on Windows there are different sandboxing techniques which are used on Linux. Linux is way better in that case, but Windows also has some sandboxing techniques. So you might want to take a look there, especially on the like even if you exploit something, are you actually admin or what do you have to do to get to be admin? Anyway, as for tricks, well, most of the techniques actually work the same like on Linux. You can use, return-oriented programming. There are like some really funny gadgets. There are maybe not so many magic gadgets, but you can use load library over the network to get a DLL of your server and just execute it, which is also kind of like a magic gadget when exploiting Windows. It doesn't always work, but it sometimes does. So yeah, that's the most important trick out there, I think. That's all I can say now. Take a look at Yuru's presentation, like Mateusz Jurczyk's presentations and blog, because he has quite a lot of good stuff there, which would be Yuru-Vexillium.org. One of the things is like Windows syscall tables, which might be useful. You sometimes need to use it. If you like break the heap enough so that when API stops working, you have to use the syscalls, and it's absolutely painful. But yeah, like it's way better, way easier to use it on Linux, because on Windows each syscall takes a gazillion of parameters for some reason. So take a look on Yuru's blog, on his presentation, publication, and so on, because there's a lot of good stuff there. And also on James Forshaw also has a lot of good stuff. Yeah, like I don't know if on Twitter you can find it, but or anywhere, but just take a look at James's stuff. He has also a lot of good stuff. And I guess like the Alex Ionescu is an obvious person to follow as well. And the Windows internal books is also really worth reading. I think we're going to just do questions until today, because we're like a couple of left and it's almost 10 p.m. So we'll be finishing soon anyway. Okay, wait, I actually didn't do one thing. Cool. Hexrabbit writes, is there any nice blog source you recommend for understanding V8 engine internals and codebase? Again, no, but where I would look at Project Zero's website, especially if they have any write-ups about V8, and also write-ups about exploits are super useful in this case, because in the write-ups and articles about exploits, especially like, you know, from Pwn to Own and such, from Pwnium, there is like explained everything, like, yeah, we did this because this works like this and this works like that, and this, like, these pieces about how something works are the super important ones. So I would probably approach it like that, and then, yeah, just play with it. Maybe it's Space, I guess it's related to the Rockstar thing. You want yarn, which should install on dependencies. Okay, just yarn, good to know. I didn't, yeah, as I mentioned, I didn't use Node.js and like yarn a lot, almost any, in all honesty. Hide the yal to your, or like hit the jal. I'm sorry, I have no idea how to read your nickname. What do you think about Ghidra? Do you think that it's a potential to replace IDA? Yeah, basically. I think it's free and there's a lot of community around it, so it has a potential to impact IDA's business and replace it potentially. A quick comparison of Ghidra's decompiler to, I guess, IDA's decompiler. IDA's decompiler is still way better. I guess Binary Ninja is kinda preparing, or they already released their decompiler as well, so this is going to be interesting. I'm quite looking forward to that. How was it that you knew to start from 2000? Yeah, I did repeat it again, but it was just in IDA, that the first 2000 bytes were copied from the file verbatim, as they were in the file, therefore I knew to just skip them. Okay, then this one I already looked at. Diran writes, not sure if anyone asks, how is your VGA project going? I didn't finish it, but I'm super close to finishing the second. I even don't know which VGA project you're asking about, because I had at least a couple of ones, but I'm pretty sure you're asking about TCP/IP over VGA, which is my most recent one. So I didn't finish the second version of it, because well, it somewhat works and somewhat transmits data super slow, but the issue is that due to unforeseen issues in the design, I decided it's a stupid idea after all. I mean, if it is TCP over VGA is a stupid idea in the first place, but yeah, it looked good on paper, and then I ran into some issues. So I'm now thinking about like Mark III prototype, which would actually use an Arduino, well, not really an Arduino, just an Atmega with, yeah, probably just Atmega with a couple of transistors and like 2 VGAs connected to it. And that's something I'm going to make before PageOut 3 is out, because I want to write an article about it to PageOut. So yeah, there we have it. But I still need to finish the review center before that. Okay. Tell us about one of the craziest challenges your team solved. I'm sure I already mentioned this one, because it's quite, yeah, I really like it. Yeah, basically my team got a binary for a custom architecture, and the task was to exploit that binary. And the problem was that there was no emulator given for that architecture, no information about that architecture. So you just got a binary, right? And yeah, like exploit it. And we are not going to tell you what CPU, how the CPU works, like what registers are there, how to decode instructions, and so on. And this is the server address where this binary is running, so you can interact with it, you can try to exploit it. But yeah, we are not going to like tell you what's the architecture and so on. So Redford was solving that, and he did in the end using like statistical methods, basically figure out the instruction encoding and written a disassembler, and after that made an exploit all without even once running the binary, because he had no way to do it on an unknown architecture, and the exploit worked and we got points for that. Now, after the CTF, we learned this is a like educational architecture used in China. So yeah, and this was the Chinese CTFs. We had no idea about it, so it turns out that like in China it was popular, so teams just solved it easily because they knew about it and they could use like ready to go emulators and disassemblers and documentation. So that was unfortunate, but still I was super impressed by Redford to like be able to solve a pawn challenge without knowing the architecture, having disassemblers, having emulators, and so on. That was like amazing. And yeah, that was, I think, the most crazy one too. And after that, you might recall that on Dragon CTF, there were some similar tasks because we decided that, hey, since this is doable, let's actually make other people do it as well. You've got some VR waiting for Half-Life, Alex. So I actually gave away my VR because I wasn't too happy with it, and I like donated it to a computer museum. Yeah, I am going to get VR, like next generation VR as well, but currently it's not, like the resolution is still not great, so I didn't like it too much, especially that I wanted to mostly for work and less for games, as in, you know, to have an infinite desktop. But in current generation VR, the text is just like awful and it cannot be used for work, but we are getting there. So yeah, I think the mistake I made was that Beat Saber came out like just when I was donating it. So yeah, if I would actually keep it if Beat Saber came out a little bit earlier. Beat Saber is amazing. I'm quite curious about Half-Life Alyx actually, but yeah, we'll see. Do you prefer explaining easy challenges instead of playing hard ones? Why do you prefer? Well, I'm going challenge by challenge in all honesty. So, yeah. But actually the question is a good question. Why am I not taking a challenge with like a 500 challenge from a CTF and work on that? I'm not doing that because it would take probably 20 hours to solve it. And the stream is 2 hours, so I prefer to just focus on challenges which take a shorter amount of time. I am sometimes explaining also harder challenges which I have solved before, but I am probably not going to do challenges which will take 20 hours with zero prior knowledge on a live stream. This just doesn't seem like a great use of time. The buffer overflow is about filling the stack with gibberish up to the return address and then changing this return address. However, the ret instruction jumps to the address at the top of the stack. Is that stack cleaning automatic then? No. So, no, everything is in the code. As in the code, usually before the ret instruction, there's a leave instruction. And that leave instruction is usually moving the stack pointer to where the return address is. And yeah, and then, or actually like one element before that and then popping something, and then the stack is where the return address is. If there is no leave instruction before the return instruction, there will be enough pops, enough like add RSP something to align to move the stack pointer to the return address. So this is all in the code, like and it's not really being cleaned up, right? It's just like the stack pointer is being moved. Because if it's moved like lower to the stack, then everything which is higher on the stack is logically no longer existing. It's obviously there, still in the memory. It can pose problems if we have uninitialized variables, but it's for like from a logic perspective, it should not be used. And that's how usually it works. So yeah, it's not automatic. Again, it is in the code. You can see instructions which actually do the proper alignment of proper moving of the stack pointer to where the return address is. Is that My Hero Academia mark? Absolutely. I got it on Intel Extreme Masters for my wife last year, along with some Zelda caps. We actually, like, my wife really enjoys My Hero Academia, and actually I also watched it. I really liked it as well. Pretty cool. Maybe not my favorite anime of all time, but I like absolutely no shame watching. Has your team ever participated in any zero-day type competition such as Pwn to Own, or stumbled upon 0 days while doing a CTF and gotten CVEs? Not in Pwn to Own, but we did get CVEs after CTFs. One was pretty loud actually. It was a really good bug in Docker, I believe. I can do a quick check actually. So yeah, I think it was this one. Yeah, like CVE 20195736, and this one was Adam Iwaniuk and Boris Poplavsky from Dragon Sector. This was a bug, I think, on either they used it. No, it was like, it started like this. There was a CTF task, I think, on Google CTF qualification round last year. And after the CTF, they still were thinking, how can we solve this task in a different way? And they found an ODay in Docker, basically. I don't think this was the only case like that. Like, on top of that, there was actually like, when we were doing with Mateusz Jurczyk, we were preparing a challenge for, there was a competition to make challenges some time ago. And that was a KrzaQ basically on Windows. And after we got we had like this crazy idea of using custom segments on 32-bit Windows and jump around them. And yeah, so we implemented that, and or rather Mateusz implemented that part because I was focusing on the graphics. And then it suddenly blue screened the Windows. And after the competition, Mateusz was like looking more into it, and he written a really good paper on what was the problem, why did it blue screen, and how to make a privilege escalation out of that, and he got a Pony Award for that as well. So that was also quite lucky. And also, again, it wasn't a CTF challenge, but we were making a CTF-like challenge back then. It was called, so did I give you a link? I gave you a link here. I'm going to give you a link here as well. There are probably some other write-ups, but like this is a random one I found on the net. Pimp My KrzaQ. That's how it's called. Yeah. So yeah, this is how the KrzaQ looked like. It was pretty animated and so on. But it is pretty hard. It is a hard KrzaQ. And we did win that competition now. Which one was it? This one. I think it was this one. Or was it? I'm not sure actually right now. I wonder where is it? Maybe it's not here. Oh well, I'm not really sure where is it, but yeah, like if you look for that on Euro's blog, I'm pretty sure you're going to find it. You mentioned somewhere in part 1.7, but you will do some streams from Hack the Box. Any idea when you might do that? I do not know. I am sorry, I do not know yet. What is your favorite anime then? Good question. I do not honestly know, because I've watched so much anime. I have quite a lot of things I could recommend, like for example 12 Kingdoms. I really enjoyed that one. From the newer ones, The Promised Neverland was pretty amazing. Then, well, Death Note, but everyone likes that, and I guess like Ghost in the Shell, especially the first one, and then the standalone complex, I really like them as well. I'm pretty sure I could figure out... Oh, I'm going to go against the curve a little, but I really enjoyed Sword Art Online. Not all of the series, though. Okay. What's going on with Dragon Sector in 2020? Not playing a lot of CTFs. Yeah, I don't think we're playing a lot of CTFs right now. This might change later in the year, but yeah, currently what you see is what you get. We'll see. Cool. I think that's we can finish for the day. So thank you for being here. Thank you to Foxtrot Charlie for being my moderator today. And next week I'm probably going to continue picoCTF unless I figure out some different thing to do. I'm kind of playing with an idea to make some additional streams, since like I'm sitting at home nowadays anyway due to, you know, everything. And so we'll think about it. So again, thank you, Foxtrot Charlie, for being the moderator. Thank you to everyone who came here today after the break. And yeah, happy hacking, happy evening, and stay healthy, and all the best. See you next time, and I'm going to leave you with some music. Bye-bye.